Now we're going to look a little bit more closely at the characteristics of exponential functions. We've done a little bit of this before, so some will be review. So what we're going to look at here is what is the initial value of this function. The initial value is the a value, or 3. The base is what's being taken to the exponential power, 2. The domain. Now, is there any number, any real number, we're not allowed to put into this function? We can put negative numbers in, that'll give us fractions. We can put fraction numbers in, those will give us radical numbers. That's perfectly fine. We can put whole numbers in, we can put decimals in. The domain for every single one of these is going to be all real numbers, negative infinity to infinity. The range. We're never going to get 0 out of this. We'll get really close to 0, but we're never going to touch 0. We'll get really, really, really small numbers, but this function is never going to equal 0. So the range for every single one of these is going to be from 0 to infinity. The horizontal intercept. Is this ever going to cross the x-axis? No. Every single time, the horizontal intercept does not exist. The vertical intercept, however, does. That's our initial value. So when x is equal to 0, y is equal to our initial value, 3. The horizontal asymptote, that is the number that it is getting closer and closer and closer to, but never touching. This is a line, y equals 0. Is it increasing or decreasing? If the base is greater than 1, it's increasing. 2 is bigger than 1, so this guy is increasing. Let's take a look at g of x. The initial value, again, is 3. The base is 0.5. That's what's being taken to the exponential power. The domain for every single one of these is negative infinity to infinity. The range is always going to be 0 to infinity. It's never going to be negative. It's never going to be equal to 0. Horizontal intercept does not exist. The vertical intercept is 0, whatever the initial value is, in this case 3. Horizontal asymptote is always y equals 0. And because the base is less than 1, this guy is decreasing. Now we want to graph each of these. I've said this before, I'll say it a million times, I am terrible at drawing digitally. So if you want to, you can take a look at these in Desmos after you've taken your notes, maybe get some more accurate graphs. But we're going to just look at these. All you need is 2 points in order to graph these exponential functions. We want our vertical intercept, 0, 3. And then I usually like taking f of 1. So if we were to plug 1 into this function, we're going to have 3 times 2 to the first power, or 3 times 2, which is 6. 1, 2, 3. F of 1 is 6. Those are the only 2 points that you're going to need to put into your homework. Everything else will be done for you. It should look something similar to this. It's not going to cross the x-axis, but it's going to get really close to it. Now let's take a look at g of x. I want to start with my initial value again. That is 1 point that I know right off the bat. And then I want to take f of 1. In this case, we're going to have 3 times 0.5 to the first power, or 3 times 0.5, which is 1.5, which is right about here. We stated that this one is decreasing, so this makes sense that the point is actually lower than the initial value this time. And that is approximately what your graph will look like.